in Tonsthes. Inside the maintenance hangar behind the terminal, the male engineer aged 25 to 30 stood in front of the female engineer rotated the simulation screen to another angle, while the young workers continued inspecting the wing surface according to the lines printed on the technical documents. Everything inside that clean and disciplined space made outsiders believe that aircraft were created only through numbers, drawings, and cold procedures with absolute precision. But right in the middle of the sound of air conditioning and the soft metallic clinks of tools, if every detail already existed on paper, why did aircraft engineers still spend hours standing in front of a structure without touching a single tool? If the drawing had already defined the entire aircraft, then what still existed inside the imagination of aerospace engineers before they made a decision?
The young East Asian male engineer slowly walked along the narrow aircraft fuselage, his eyes studying every rivet position and
subcollets. The young East Asian female engineer no longer looked directly at the numerical display, but constantly imagined inventions.
The young workers began to realize that these engineers often remained silent for a very long time before changing even the smallest detail.
And from that strange silence, the central question of the entire story finally began to emerge more clearly than ever before.
In the aviation industry, technical drawings have always been considered the most precise language for transmitting the structure and operational principles of an aircraft.
Every young worker in the hangar learned how to read every symbol, every tolerance, and every structural layer to ensure that no action ever deviated from approved standards. The young Caucasian male engineer also began every working day with detailed drawings, because no engineering field allows dangerous improvisation like aviation does. The simulation data confirms the systems are operating within the approved limits.
I'm cross-referencing the design documents now. Everything checks out.
Under normal operating conditions, the matte gray narrow-body aircraft looked like a perfect assembly of millions of precisely connected components.
The young workers inspected every joint exactly according to the documents they received, because aviation never allows anyone to work based on instinct alone. The entire maintenance hangar behind the terminal operated like a giant machine, where everyone followed procedures with almost absolute discipline.
From the outside, it seemed that an engineer's job was simply to check whether reality matched the drawings and to correct any deviations if they appeared. The drawing therefore became the center of the entire operational system, while imagination seemed to belong only to artists and not to aerospace engineers.
But the longer they worked inside this environment, the more the young workers realized that the most important decisions often appeared where the drawings could not fully explain everything.
The young male engineer often stopped in front of a detail that was completely within standard, yet still demanded another inspection.
The young female engineer sometimes requested changes to maintenance procedures even though every numerical value still remained within officially approved safety limits.
The strange part was that they did not always explain things immediately with a specific number, but often began with an imagined possibility of what could happen later.
They imagined the aircraft shaking violently during hours of turbulence at high altitude, instead of operating only under ideal conditions.
They imagined a tired worker accidentally tightening torque incorrectly in the hardest-to-see location, and how that could trigger a chain of consequences after thousands of flights. They imagined material expansion happening slowly across many seasons of temperature changes, even though the metal surface still looked completely normal at the present moment.
The young workers began to feel confused when they realized that aerospace engineers did not only look at the aircraft in the present, but also saw its future.
The drawings only showed the shape of the structure, but the engineers constantly thought about invisible forces that had never appeared before their eyes.
The greatest contradiction finally began to emerge clearly inside the quiet maintenance hangar behind the terminal.
If aviation is a field of absolute precision based on data, then why do aircraft engineers still need to imagine so much before making a final decision?
The answer began to appear when the young male engineer explained that a drawing could never fully contain the real behavior of an aircraft living inside an actual operational environment. A drawing only describes the structure in a static state, while the aircraft in reality is always moving, vibrating, deforming, and enduring pressure through every hour of flight. The young female engineer understood that the most important thing was not how the aircraft was designed on paper, but how it would react in millions of situations that could never be completely predicted. Therefore, aerospace engineers do not only read drawings, but must also imagine the invisible movement of force, temperature, pressure, and material fatigue over time.
When they looked at an aircraft wing, they did not only see metal surfaces, but also imagined airflow bending the structure at hundreds of kilometers per hour.
When inspecting the fuselage, they did not only see rivets but also imagined cabin pressure continuously stretching and compressing the material through thousands of flight cycles.
When evaluating a system, they did not only think about the present, but also imagined what would happen if a tiny component failed at the worst possible moment.
That is why aerospace engineers always think beyond drawings. Because drawings only describe shapes, while
What they imagined was not random creativity, but the ability to mentally simulate things that had not happened yet, but could completely happen.
In aviation, safety does not come from seeing problems after accidents occur but from the ability to imagine problems before they even exist.
the young workers finally began to understand why these engineers often remained silent for such a long time before making a decision that seemed incredibly small. Because behind every small change, there were countless invisible scenarios they were trying to imagine before the aircraft ever left the ground. The young male engineer often viewed drawings as the beginning of thought, while young workers at first viewed them as the end of the job. The young female engineer did not only read technical numbers but constantly compared what the aircraft was designed to do against what it might be forced to endure in reality. The greatest difference between someone who only follows drawings and someone who truly designs aircraft lies in the ability to see things that have not appeared yet. A young worker saw a perfectly standard metal panel, while an aerospace engineer saw the structural fatigue lifespan after years of continuous operation. A young worker saw a system operating normally, while the engineer imagined what would happen if a small error appeared during extreme weather conditions.
Drawings help create the shape of an aircraft, but engineering imagination is what allows the aircraft to survive in the constantly changing real sky. The aviation industry, therefore, is not only an industry of mathematics and mechanics, but also an industry of highly controlled imagination.
Engineers do not imagine things to dream, but to see danger before danger ever has the chance to become a real accident. That is exactly why their work never stops at copying drawings precisely, but always goes further than what already exists on paper. The young workers gradually realized that the best engineers were often the people capable of seeing invisible things more clearly than others. And sometimes those invisible things were only a tiny vibration, a tiny temperature change, or a rare chain of failures that had never appeared before. But inside the minds of the young engineers, that aircraft had never truly stood still, because they understood that an aircraft was safe not because its drawings looked beautiful, but because there were people capable of imagining danger before it ever happened. The aviation industry therefore teaches humanity a very special lesson, that true precision does not begin with seeing the present, but with the ability to predict the future. And in the end, what aircraft engineers truly imagine beyond every drawing is not only the shape of an aircraft, but its entire fate in the sky. In the final quiet moment of the work shift, everyone inside the hangar began to understand that the imagination of engineers, what keeps an aircraft safely alive in the sky, is not only what humans are capable of drawing, but also what they are capable of imagining.